This is part 3 of the Financial Solver Lesson 8 video series. This video is going to be looking at perpetuity. But before we get to that, I just realized that in part 2 I forgot an example, which is question 4. I'm going to go over this first before I get to perpetuity. Question 4, Genevieve wants to invest her inheritance from her grandmother of $100,000 into an annuity that offers an interest rate of 4.5% per annum compounded quarterly. If she wishes to take a quarterly payment of $3,000, this annuity will last for how long? Let's first set up a template and put in the information that we do know from the question, and obviously from here what we're looking for as well. Now we're going to be careful with our PY and our CY. They will be the same amounts, but what these amounts will be is dependent on the context of the question. So what we don't know is our end value, how long this is going to last for. This is what we're trying to figure out. The percent that the bank is going to offer is 4.5. The present value, or how much you're initially given to the bank, it's always a negative if it's an investment, and it's $100,000 in this case. Yeah. The PMT, or the payments that are made per time frame, in this case per quarter, is $3,000. And we're going to see how long this will last for until it's all run out, so our future value will be $0. Now the PY and the CY, we're generally used to using 12 because it's compounded monthly. But we would be using quarterly. It's compounded quarterly, so she's going to be taking a quarterly payment. There are 4 quarters within a whole year. So PY and CI will be 4. We'll go ahead and clear this compound. In value, we're going to skip 4.5 for the interest, negative 100,000 for the PV. PMT 3,000, so how much she wishes to take out, 0, 4, and 4. So our end value is 42.01266402, and this is closest to 42. That 0 there, we'll just keep it at 42, or in other words, 42 months. So this belongs to A. Alright, let's get into perpetuity. Perpetuity is essentially the same thing as annuity, but the difference is when you get regular payments, or when you do withdrawals from your investment, this is going to be exactly the same as the amount of interest that you earn as well. What do I mean by that? So let's say me, let's draw me. This is me. Yay. So this is me, and I've got some money, and I've got X amount of money. Now again, we know that with perpetuity or annuity, you give this money to a financial institute, you give it to the bank, and the bank says, oh, thank you for keeping the money with us. You will get an X amount of dollars that's saved within your account, and then we'll work out a percentage of some form, maybe compounded monthly or weekly or fortnightly or quarterly, yearly, and we'll pay this extra as a way of saying thank you. Now the difference between annuity and perpetuity is that when you take money back, this amount of money that you take back isn't necessarily a fixed amount that you're going to decide. It's actually the percentage of that amount that you get, or in other words, the interest. So this is actually going to create a cycle, because when you give the money to the bank and you keep that money there, and then the interest is given back to you, what you're left in the bank will be exactly the same as what you started, because you're only getting the interest given to you, nothing more, just the interest. So then when that money stays in there and then the next time frame goes, the compound interest is applied to that amount again, that produces interest. That interest is given back to you, and then you start the cycle again. So this is why people that accountants say that if you were to win the lottery of some sort, the lottery is a lot of money, what you should do with this money, or any large amount of money, is to put it into what's called a perpetuity account. So that way you're living purely on the interest of what the bank is giving you, because in that sense it's free money really that the bank is giving you for using their services. And obviously the more money that you put into the account, the more interest that you'll get paid to you. In fact, if you were to put money into a bank, instead of just putting getting the interest of the percentage of what's in there, maybe you can just get a little bit less than that. So that way, what's left in the account is your X amount of what you started with, plus a little bit something. But then when that percentage is taken off, it's gonna give you a little bit more in return. So you're still living off the interest amount, but then your bank account is still getting a bit more money. Now this isn't a financial advice video. This is just what I would do. This is what I'm currently doing with the amount that I have now, because free money is good money and it's good for the economy. All right, let's have a look at this example here. The university mathematics faculty has $30,000 to invest. It intends to award an annual mathematics prize of $1,500 with the interest earned from investing this money in a perpetuity account. What is the minimum interest rate that will allow this prize to be awarded indefinitely? So the university has $3,000 to invest, and they are relying on the bank's interest to be able to get a little bit of interest back. Not a little bit, but specifically $1,500. And what we need to do is, using the financial solver, figure out, oh, hey, what interest can the bank offer? What's the best they got? It says minimum. It doesn't have to be locked in amount. The higher the percentage, the more money you will get. So that's fine. It's just, we need a minimum bound of some sort. So this will be, let's look at the context. What's the time frame? This is going to happen per year. And the thing is, it doesn't say that this is compounded monthly or daily of any sort. So it's safe to say this is going to be compounded once per year. And if it's going to be compounded once per year, which is effectively simple interest, your end value is just going to be 1, because it's just 1 year. You're not going to put 12 months or anything like that. You're just going to keep it as 1. The interest rate is what we're looking for. This is what we don't know. Now, a present value is how much you're going to invest. Always a negative, and it's always given within the question. We're going to invest $30,000, so it's going to be a negative. And what we want to get out of this at the end of this 1 year is our payment, which is $1,500. We want to get this. Now the future value is, once this money has been taken out, we want our future value to still remain the same. We don't want this amount to dip down. We want to keep this money in here. And our PY and CY cycle, how much payments that are going to be happening per year? Well, this is just going to be 1. It's just going to compound once per year. So effectively, we're just using simple interest, disguised as a compound interest question, but changing this or keeping this as the same amount is what makes us different. So let's put this into the calculator. We'll put 1, keep that blank because that's what we're looking for. Negative 30,000, 1,500, and 30,000. Remember, your future value, even though it seems like as though the future value we want to keep, we are giving the money to the bank and it will be a negative, is what we do here. The future value is what we want to have in order to put back into the bank. So this stays positive. It seems a bit counterintuitive, but it does say positive. Your PY and your CY cycles are 1. Go ahead and press that interest rate and you will get 5. So the mean interest rate in this case this will be 5%. So the bank can offer any percentage higher than that, but at minimum it needs to be 5. If it was 4%, eventually when you take that $1,500, you're going to be given less interest, so that will bump that future value down, which is a no-no. All right, Frida has invested $95,000 in a perpetuity that offers 5.5% per annum compounded quarterly. She will receive a payment of $1,306.25. How much money will Frida have after 5 years? It's a bit of a trick question, because if it's a perpetuity account, it is assumed that the money will never run out. So after 5 years, she's effectively still going to have the $95,000 that she began with. If you see that this says annuity, that's when you will use your financial solver to work it out. But if it's perpetuity, your future value will always be the same as your investment. So this is $95,000. It's repetitive. Trick question. All right, question 6, last question, and the last example for this financial solver, and for the whole topic of number patterns and sequences. A benefactor of a college has been approached to provide a monthly Year 9 scholarship. He is able to get a financial institution to offer a long-term interest rate of 3.6% per annum, compounded monthly, for his $75,000 he invested. What is a monthly scholarship he can donate? So we're relying on what 3.6% per annum compounded monthly of interest on top of this. Whatever interest amount he gets from this is what he can offer as a scholarship amount, and any more, that $75,000 will go down. Any less, it gets actually added extra, but we want to see what that maximum value we can take out is. So last time we'll set up our template, NIP, need a PV, PMT, FV, and PY and CY. So the number of compounds, this is going to be compounded monthly, and we're just going to see this within the year. So it is 12 months within a year. The interest rate, 3.6. The present value rather is negative 75,000. It's an investment, it will be negative. The payments that we're going to get at the end of the each month is what we don't know, or end of the year rather, is what we don't know. So this is what we're trying to figure out. And then the future value after all of this will again need to remain at 75,000. These two will always be the same, just one will be negative, one will be positive. The PY and CY will be 12. Go ahead and put this into the calculator. So when we get our amounts, this ends up being $225. Now I did say that it was at the end of the year, but because it's compounded monthly, this is the monthly scholarship they can donate. So the scholarship monthly scholarship is going to be $225. And this is the locked amount that you can take out based on the investment that or the interest that the bank gives to you at 3.6. And this concludes this video of perpetuity and for the financial solver, and the last video for this series. Go ahead and approach the project that you will be provided for these 3 set videos. Any questions, ask me within the chat system of Microsoft Teams, and I will see you guys in the next video series, which will be matrices. Until then, take care, and I'll see you soon.